We have the function f of x equals 1 over x squared minus 3x. We want to find the derivative of f of x. Now we're digressing a little bit because people are having a lot of trouble with the rules of differentiation. Okay, now this involves, this can be done using a quotient rule, but you have a constant function up on top. You really don't need to use the quotient rule here. It's really better if you use the chain rule. So let's think about what the chain rule is telling us again. The chain rule tells us that since we first, if we plug a number in for x, the first thing we're going to do is evaluate, to evaluate 1 over x squared minus 3x, we first evaluate x squared minus 3x. For example, if x equals 5, x squared minus 3x equals what? 25 minus 15 is 10, if I'm doing my arithmetic correctly. Now, after we evaluate that, we get our result for x squared minus 3x. What do? We do the reciprocal of that number. So if x equals 5, we get the reciprocal 1 over 10. So we've evaluated this thing in two steps. We first evaluated x squared minus 3x to get 10, and then since x squared minus 3x is in the denominator with 1 in the numerator, we simply take its reciprocal and get 1/10. Now I know that when you evaluate a function, you're just going to look at this and you're going to put a 5 in here and a 5 in here and you're going to get 1/10. But if we think of it in steps, we first evaluate the denominator, then we do the reciprocal. That means that this function is a composite. Composite of what? It's a composite of the reciprocal and x squared minus 3x functions. Composite means first we evaluate one, then we apply the other. Now the reciprocal function, I'm going to call the reciprocal function f of u, and that's 1 over u. And then the x squared minus 3x function, I'm going to call that my g of x function. And then I'm going to note that if I do f applied to g of x, we get what? F of u is 1 over u, so f of g of x is 1 over g of x. And of course, g of x is x squared minus 3x, so that's 1 over x squared minus 3x. So there is this function expressed as a composite. Now we have a chain rule that tells us how to take the derivative of a composite. And I'm going to write something off screen and then I'll be right back. Okay, we have the rule that says f of g of x prime, derivative of f of g of x, is g prime of x, the derivative of g prime of x, plus the f prime function evaluated at g of x. Now the reason for this, well, g prime of x is how fast g changes, okay? And then f prime of some number is how fast f changes with respect to g in this case. Now if f changes at some rate with respect to g, and g itself is changing at some other rate, then the rate of change of the composite function will be the product of those two rates. Whether that makes sense to you or not, that's a kind of a vague explanation, but that gives you a sense maybe of what could be going on here. Okay, whether you understand that or not, we can apply the rule. This says we got to find our g prime function. Well, g is a function of x, so we find g prime of x. Well, here's our g function. Our g prime function is very clearly 2x minus 3. And if it's not very clear to you why that's the derivative, you really need to review derivatives somewhat before you can really understand what we're doing with composites. You need to be able to do the derivatives of your composite, of your power functions. Now, f of u, what's the derivative of f of u? Now, the derivative, I haven't been real specific about what the derivative is with respect to, but since your f function is 1 over u, we're going to take the derivative of f with respect to u. Now, 1 over u is u to the negative 1. It's a power function. You get, when you take the derivative, you get negative 1 u to the negative 2, which is negative 1 over u squared. So that f prime of u is negative 1 over u squared. Now, evaluating g prime of x, well, we got that. What's f prime of g of x? Well, I'm just going to write the whole thing out. G prime of x, f prime of g of x equals 2x minus 3. That's the derivative of our g prime, multiplied by f prime of g of x. Well, let's see. F prime of u is negative 1 over u squared. So what's f prime of g of x? You should think this through before you watch what I say. F prime of g of x is negative 1 over g of x squared. And that's equal then to, write out the 2x minus 3 first. G of x is x squared minus 3x. So it's this times 1 over x squared minus 3x quantity squared. And then we can do some simplification. There's not a whole lot of simplification that can be done, but we just write this as negative 2x minus 3 over x squared minus 3x quantity squared. This is, it can be factored. You can factor out, you get an x times x minus 3, and then you got to square that, so you got x squared times the quantity x minus 3 squared. This is already factored, and this factor doesn't match any factors of the denominator, so there's no further simplification that can be done. Now, the quotient rule also gives you the same result, but I'm not going to work through that. You can work through the quotient rule and see if it gives you the same result. But this is one you really want to do as a composite.